Hey guys, welcome back to the shop. Today we're going to take a bunch of high carbon steel rods and turn it into pattern welded Damascus steel and turn that into a really cool dagger. Anytime you're trying to forge weld multiple small pieces of steel together, a canister is perhaps one of the best ways to go about doing this. So as usual, I'm using some mild steel square tubing to create a can to put these pieces of high carbon steel rod into. Go ahead and deburr it because experience has taught me that if there's something that I'll cut my finger on, then I probably will. And removing the seam from the inside, because if I don't, that will show up on the finished billet afterwards and will have to be addressed. I need a couple of mild steel end caps, and they need to fit fairly tightly, but a little bit of gap isn't going to hurt anything. In this case, I didn't get them quite as tight as I wanted to, so using a little length of angle iron so the cap could just sit right where I wanted it while I tacked it and then welded the seam up with the arc welder. Seemed to work pretty good. Now that I have the one end cap welded on, I can coat the inside with white spray paint. This is to keep the contents from welding to the can. The titanium dioxide content creates a non-welding barrier during the forge welding process. This is W1 high carbon steel rod. Now it comes nice and clean, but I went ahead and made sure that the surface was free of any kind of corrosion, anything that would inhibit a forge weld. Sprayed it down with WD-40, chopped them up into pieces, and then painstakingly deburred each one on each end. Now you'll notice some larger rods in there. That's 3/8 inch 01 tool steel rods, and the only reason I had those was for additional space filler in the canister. I did not purchase quite enough of this 3/16, or is it 5/32? I don't remember. I think it's 3/16 inch rod. And so to fill the canister up, I put 4 pieces of this 3/8 01 in the corners, and we got a pretty decent fill up there. Now I'm going to fill up all of the remaining voids with 1080 powdered steel, which contains 4% nickel powder mixed in the powdered steel. Quite a lot actually goes in there, even though the canister already looks pretty full. Multiple spoonfuls of this powdered steel goes in, and then making sure that it is packed down as tightly as possible so there are no voids or air pockets in the canister. Once that's complete, I can weld the other end cap on for a nice clean can. I will note that you do need some kind of a vent hole, so while I'm welding that last cap on, I will make sure that the little pinhole presents itself and you can see it kind of off-gassing, and with my arc welding that's not so hard to do, but if you weld stuff airtight you do need to drill a tiny hole in the canister somewhere. Get it up to heat, and that takes about 20-30 minutes. Press it in the square dies, and you'll see the billet sticking in there, the can sticking in the dies. That's from residual flux that is stuck to the dies that came off the bottom of my other forge with other cans, and so there's no reason it should be sticking, and it's rather frustrating because there's no flux involved in this forge weld process and we're still dealing with it, but that's just the nature of the beast. There's the can, and we've pressed it multiple times so we have a good solid billet inside. After it's cooled off a little bit, we can start cutting it open and see what we have. You'll notice the steel canister comes off pretty easily. Once you get the seams cut in it, it doesn't really stick to the billet. I needed to clean up the corners a little bit. I cut into them with the cutoff wheel So taking out any grooves and irregularities before continuing the forging process is important so we don't end up with any cold shuts or nasty stuff like that in our billet moving forward. I'm not going to forge it out very much. I'm just going to square it up a little bit and then round off the corners in preparation for the next step. And the next step, drum roll please, is to twist the billet. Now this proved to be a bit of a challenge due to the size of the billet, the cross section, a little bit thicker than you want to be twisting by hand, but also the fact that it was so close to the forging press frame here. I didn't have any clearance to work with, and those two things combined made it pretty tough to get twisted. But I was able to work at it little by little and return it to the forge multiple times to keep it at a good heat, and we were able to get the job done. As soon as it started to cool down a little bit and stiffen up, you weren't going to do much twisting at all. So it took a little while, but I got the amount of twists on it that I wanted. Didn't count, but a good tight twist. And pressed it out a little bit here and there as we progressed, so it's a little bit longer than when we started. But I needed to keep that wide enough to accomplish the pattern that I'm going with. So pulling it out of the kiln there, and that was in annealing cycle so that it will be soft enough to now cut the billet on the bandsaw. This bandsaw is not really set up for this type of cutting, so getting the cut started was a little challenging, but once that was there, we could just slice off some slabs on either side. The reason I'm doing this is because when you twist a billet, there is a range of patterns that present themselves throughout the thickness of the billet. And the pattern that I'm after is towards the center. So after cutting and grinding, you'll see what we have here, a slightly tapered billet with the end there that doesn't have the twist on it, and that's for the tang. So now we can go ahead and forge the blade profile. If I'd been able to cut those slabs a little cleaner and more consistently, we might have been able to use those on some future project and get more out of this whole billet, but I didn't accomplish that quite as well as I wanted to. You'll notice that I'm not forging the bevels on this dagger here. We will just be doing the profile, which includes the tang, and leave it at that. The reason for this is since you have 4 bevels involved in a finished dagger, it can be a bit of a challenge if you forge and or grind the blade partway and then go into the heat treat. Any kind of warping or twisting that presents itself is more difficult to deal with when you have 4 different bevels you're trying to line up. So doing it this way, you can fully heat treat the blade before there's bevels on it. And at that point, everything is stable. Once you get it out of the temper, then you can go ahead and grind everything, and there's not going to be any further movement, at least very little, of the steel. So we did our grain refinement, normalizing, and grain refinement cycles into the quench. It is all tempered now. I've ground off the scale, and now we're going to surface grind it. Now this tool is a great addition, great accessory for the KMG grinders. Our friends at Beaumont Metalworks sent this over, and I was excited to get this out. Been waiting for a while. This makes getting things flat and true much easier. Pretty simple to set up, and I'm pretty happy with the results on it. I grabbed my calipers and checked the consistency along the length, and it's good. It's right there. There's no variation. It's within 1/1000th easily. One of the things I've become more conscious of recently is, the fact that having flat, true surfaces really does help in laying out, mapping out your blade and fitting guards to all of that stuff. So in lieu of an actual surface grinder, standalone surface grinder, that accessory is really great to have in the shop. Got my center line scribed there, and basically the point or the goal here is to simply make identical blade halves on either side of that center line. And so that's what I'm grinding out here using the work surface or the work rest, so I have a nice 90-degree surface right there. Yeah, you shouldn't use your calipers to scribe stuff. This is my beater pair, but it'd be better to have a center line scribe for laying out your edge centers. So the goal is to grind 4 bevels here that are completely equal and lined up. I got pretty close, I think, and it turned out pretty decent. It's a little bit of a challenge. Put those shoulders in the ricasso to fit the guard up against, and we'll go ahead and hand sand this whole blade all the way up to 800 grit. Put some time in there, and it's interesting how easily those bevels can move around that center line on your double-edged blade, so you have to be careful with that when you're hand sanding. So I did fit this stainless steel guard up, a combination of hand filing and then finally some hot fitting at the end there. And I'm actually just going to go ahead and eyeball this whole guard process from here out, which is not as precise as using a template would be. I need to probably make a little template for a small boot dagger sized guard like this. But today we're just going to hand sculpt it, and I think it'll turn out alright. Piece of elk antler tine for the handle, and with this stick tang construction, it's a pretty easy fit up. Just had to use a drill bit to put a hole through the antler, not all the way through, most of the way through, and then widen it out a little bit, and it went together pretty easily. I was debating a little bit on how to finish the juncture between the antler and the guard. In the end, I went with a leather stack in between, which you'll see. So we've got this etched. That's a multi-part process, but don't need to go into that in detail. Everything's epoxied together, and that's one good thing about having a large vise is you can actually use it for a knife handle vise or something like that if you need to. And we'll drill a hole for a pin through the tang here for extra security on this handle. This is a nickel silver pin to match the stainless steel guard. They're not exactly the same color actually, but it'll still sort of fit the overall look, I think. All we have to do now is shape the leather stack transition between the antler and the guard, and inevitably we'll have to sand on the guard and the antler a bit as well. The small wheel attachment on the grinder makes this a bit easier, but you do have to be careful because anytime you have hard and soft material matched up together, the soft material can get ground away real quick and the hard material hasn't been hardly touched, so it's a bit of a tricky process. Alright guys, that about wraps this build up. I'm going to show you some close-up pictures of it in just a second here. It turned out pretty cool. I enjoyed building this. Hopefully you enjoyed the video and maybe learned a little something along the way. If you want to support the content, check out the links in the description below. As always, I appreciate you guys watching, and we'll see you on the next video.